All right, so our lesson today on adding and subtracting. So I'm going to quickly remind you what you know but forgot. How do you add fractions that are not polynomials? How do you add 1/2 plus 1/3? And the answer is, step one is to make the denominators the same. And you want to do it for multiplying and dividing, but no. Multiplying and dividing, the denominators do not need to be the same. Adding and subtracting, the denominators need to be the same. After the denominators are the same, then you add or subtract only the numerators. The denominator stays the same. That's the basic technique, right? The denominators need to be the same. You add and subtract only the numerators. Now, what happens with polynomials? Most of the time when you want to make the denominators the same, you're going to have to factor so you know what to multiply to make them the same. And the basic rule is whatever I multiply the denominator by, I got to multiply the numerator by so it stays the same. So, number one, rewrite the problem using a common denominator. Only combine the numerators. We keep the denominator the same. And our answer at the end, you might need to factor and simplify it to write it in lowest terms. All right, ready? Nothing beats practice together, right? That's how we learn it. Not me talking to you about it, but practicing together. So, number one, you're adding. The first thing I look at when adding, are the denominators the same? Yes, done. That means my denominator is that. I just write it over again. So what did I look for first? Do I have common denominators? Now, what do I do with the numerators? 13 plus 5. Make sure you only add like terms. They are like terms. And then the last step, is there a way to simplify that one expression? So what big number goes into both 4 and 18? So it's 2, right? So it becomes 2 and 9. How can the a and the a squared simplify? Well, they subtract, and how many more a's do you have on the bottom? Just a, right? So if I put it all together, what's your answer? 9 over 2a. Obviously, if the denominators are the same to start with, that makes this question fairly simple, right? The challenge is going to be when you have to make them the same. Let's keep going with simple, and then we'll build it up. 2, what's the first thing I look at? Are the denominators the same? Next thing, be careful. Whenever you subtract, you got to know it belongs to both. What's 9 take away 7? And what's 12 take away 2? And we're just going to be careful. If the second 2 is negative, you're subtracting a negative, which would make it adding. Like, we're just going to be aware when you're subtracting, the signs might change. Do you see something that is factorable? I'm going to do it that direction. So if I look at 2 and 10, what number goes into both evenly? So factor out 2. And then what do you notice is that 2 goes into 16 how many times? So our final answer is x plus 5 all over 8. Let's keep going. Look at number 3. Are the denominators the same? So we write it down. Can you combine like terms by adding? So when I combine like terms, I have 1y squared. 8 plus 2 is how many y's? And then the constant at the end is 21. Once I have my answer, I'm looking to see if that's in lowest terms. So you combine like terms. Do you know how to factor the numerator? Do you know how to factor a simple trinomial? What two numbers multiply to 21? And the same two numbers add to 10. In order doesn't matter. Do we know what's 3 and 7? Is that getting simpler? The denominator is called the difference of squares. What does that mean? Well, what's the square root of y squared? What's the square root of 9? So one's y plus 3 and the other is y take away 3. Do you see any common factors that we strike out? So y plus 3 divide out, and that's it. So our final answer is y plus 7. And in the denominator is y take away 3. All right, number 4. I'm going to give you a shot. Start. Look at the denominator. Can you combine like terms? Can you factor and simplify? And then your answer. And if in a video there's like a big pause, you know what you can do with a video?
Fast forward.
Oh yeah, you can fast forward, that's right. And so you don't have to wait for this pause. And if I go too fast, you can always press pause, right? So you are in control. Have you ever wanted to control the teacher in terms of how fast or slow they go? The power. So keep working it all the way to the end. I'm going to start doing the problem, but you have to look to see if you did it right. So if you look at number 4, the numerators are unlike, so you can only put them beside each other. Did you do the first step correct? Or did you put down negative 15? Second, do you know how to factor? So the denominator, what number goes into both evenly? 3. When I see a binomial subtracting, my mind right away goes to a difference of squares. So square root of 1, the square root of 16, a squared. So do you see where 1 plus 4a and 1 take away 4a comes from? Then, do you see that these are opposite factors? They're not exactly the same. They're opposites. So when they strike out, what's left over for opposites? And you don't need to multiply. You could write the answer as negative 1, subtract 4a, or this way. Both are good. So when I finally get my answer in lowest terms, it's negative 1, 1 plus 4a over 3. All right, try number 5. Number 5. At first, I want to do them for you. Then, I want you to have a chance to practice the skill. And if you practice the skill and don't know if you did it right, then the practice isn't very powerful. We need to practice and know that we did it correctly. Oops. 8. Did you get n squared plus 2n? Take away 8. I almost made a mistake, but I double checked. Whenever you subtract, right, make sure that you're subtracting correctly. So negative 7 subtract 1 is negative 8. And one of my indicators were, when I didn't get that, it wasn't factorable. So I'm assuming there's going to be a lot of factoring, right? And so if I get to a roadblock, it might be the final answer. But if I think I'm going to factor and it's not factorable, I'm going to go back to make sure I did the basic stuff correct, right, with science? So to factor the numerator, positive 4 and negative 2. To factor the denominator, it's positive 3 and negative 2. So n subtract 2 strikes out, and I'm left with n plus 4 and n plus 3. All right, try number 6. Then we're going to practice how do we make the denominators the same. That's going to be the big skill. This skill is a repeat from Friday, right? A repeat from your quiz you had this morning. Can you factor and simplify? Which is good. We need to practice that all the time. So when you did the first step, does it match mine? When you do the next step, are you looking for the greatest common factor? Dividing. Now, the denominator, I'm going to do this on the side. So in the margin, I'm going to do the denominator. So I have 6 times 1, which is 6. And I have negative 5. So what two numbers multiply to 6 and add to negative 5? So because 6 is positive, you're adding. Then I'm going to write it down, the denominator only. I'm going to do a substitution. I'm going to substitute out negative 5k and put in negative 2k and negative 3k. And then I'm going to factor by grouping. Some of you still need this practice, right? When it's not a simple trinomial, the way you get stronger is by practicing. Making a mistake and keep practicing. It's hard to get stronger watching me do it and copy. So again, I'm going to factor out the first two terms only. What do they have in common? 2k, divide. And I'm left with 3k subtract 1. The next two, they have a negative 1 in common. Divide, and you have 3k subtract 1. Now, I'm just going to go back to the question. So I have 3k subtract 1, and what's left over is 2k subtract 1. Now that it's completely factored, can you see what strikes out? And what's left in the numerator is 7k, and in the denominator is 3k take away 1. Done. All right, let's practice now the next level. The next level is the denominators are not the same. What do I do then? So let's look at number 7. My goal is, can I subtract a rational? Are the denominators the same? No. How can I make them the same? So in this example, when I look at 2x and x, I'm also looking at the big numbers, the coefficients, and the variables. They have to match. So do you notice the x's match, but the 2 and 3 do not? So simply put, what number does 2 and 3 both go into evenly? So 2 and 3 both go into 6. So how many 3's are in 6? So for the one fraction, I'm going to multiply top and bottom times 2. How many 2's go into 6? So top and bottom times 3. So whatever you do to the denominator, you have to do to the numerator. So 3 times 15 is 45. 16 times 2 is 32. And what's the common denominator we just came up with? 6x. So the 45 take away 32. And then what number goes into them both? So we're going to divide top and bottom by 3 and get 5 over 2x. Right? Did I subtract right? 45 take away 32. That's not 15. What's 45 take away 32? 13. And then we're done. I can do this. Number 8. It's not about making a mistake, right? It's not being stubborn. Going back. Yep, I made a mistake, right? And then go. 8. What's the goal for 8? Is to make the denominators the same. So first I look at the coefficients, the big number. How many a squares do I have? 1. How many a's do I have? I want the coefficients to match. So what do I multiply times so they match? So I'm going to multiply top and bottom times 8, and now they match. Look at the second denominator. Now the coefficients match. Does a squared and a, do they match? What do I multiply times? So a squared becomes a squared, right? What does this a need that it doesn't have? So multiply top and bottom times a, and you end up with 32a over 8a squared, and then 7a over 8a squared. Are the denominators now exactly the same? Subtract the numerators. Are these like terms? Make sure I don't subtract wrongly. 32 take away 7. What number is that? Tell me it's 25. Then when I subtract, there's one more thing that can simplify. So there's no number other than 1 that goes into 25 over 8. That's lowest terms. What happens to the a in a squared? So 1 take away 2, we're left with how many a's in the denominator? So our final answer is 25 over 8a. Turn the page. So, this is where we need to be today. Adding and subtracting, where the denominators are unlike, and you see binomials, trinomials, and you have to have the skill to factor and know what to multiply to make the denominators the same. Are we ready to practice together? So step 1, are the denominators the same? No. Next step, look at only the denominators. So, for me to understand how to make them the same, and they're not monomials or binomials or trinomials, I have to factor, and then once I'm factored it, I can see what I need to multiply. So 5k take away 10, what do they have in common? Just the denominator. And when you divide out of 5, what are you left with? And I want you to notice it's now simple to think, what does the second denominator need that it does not have so that the bottoms can be the same? 5, top and bottom. Are they now the same? Remember, you just write it over again, right? Don't mess with it. Once you find the common denominator, that's it. Write it over again. Now, the numerators, k squared, there's no like terms. What's 16 subtract 20? Is that negative 4? Can you factor it? Like, does it right away pop to you now? Hey, that's a difference of squared. Like, it pops. You've done it enough. So, to factor the numerator is k plus 2 and k subtract 2. And then, is there a common factor that strikes through? So, what's your final answer? K over 2 over 5. All right, number 10. We'll eventually get there. You are going to do it first, then me. Let's look at it again. Are the denominators the same? No. Is it obvious what to multiply to make them the same? No. So what do I have to do first? Factor. So the first one is prime. But the second denominator, what two numbers multiply to 24? And you're going to start doing this in your head. If it's a simple trinomial, you don't need all that other stuff, right? What two numbers multiply to 24 and add to 11? 3 and 8. Now, is it obvious? What does the first fraction need that the second one has? What's missing in the first denominator so they can match? Y plus 3. And whatever I do to the denominator, I have to do to the numerator. Now, we have to distribute here because we have to combine like terms on top. Meaning, I got to go 7 times y. I have to go 7 times 3. But the denominator stays the same. We know the common denominator. So now we're ready. Are the denominators the same? The numerators, did we distribute so we can combine like terms? And we're ready to go. So 7y, there are no like terms. 21 plus 35. 56. Do you see there's one step left? Do you know your times tables? So your spider sense goes off? Does 7 go into 56 evenly? So how many times? And then can you follow through in your brain and go, wait a second, there's a y plus 8 in the denominator, so my final answer is really 7 over y plus 3. All right, number 11. I'm going to do my laps, get my exercise in the morning. So I want you to try number 11. I want you to practice correctly. I want you to know any question I make you do, I always give you the answer to, unless it's a quiz or test, right? Always. Your homework, what we do in class. And I don't want you to be afraid of making a mistake. I want you to be afraid when you get lazy. When you do the work and you're afraid to go back because you don't really want to go back and correct your mistake. That part I want you to be scared of. So I'm just saying, like, where are we confident with this? I'm pretty sure none of you have ever done this in your life, correct? And you guys are doing great as I walk around. When you are done, put a box around it. Have the courage to ask somebody in your group to see what their final answer is. And see if you guys match. And if you don't match, communicate. See at what step you were different. And if you did all your work to the end and someone's stuck, it's okay. Support them. Do you guys check? You guys are powerful, both of you. Trust me. I see all the quiz scores. Right? This is a powerful, right? So look. Well, I'm hearing good conversation. And again, on the video, you can fast forward this stuff. We get a final answer? Right? Is that what everybody in your group got when they combine like terms? Did Mr. Thomas get that? I see some good work in talking to each other. So let's make sure we did the first thing correct. Did you go positive 2 and positive 3? To make the denominators the same, did you multiply top and bottom by x plus 3? So when you combine like terms, in the numerator, x squared, we have 1x, right? And what's 1 times 3? So negative 5 plus 3 is negative 2. To me, that might have been the hardest step, is to get here. The next step, I hope, is simple. What two numbers multiply to negative 2 and add to 1? And then the easiest part, can you strike out the factor that's common on the top and bottom? And did you, in your group, somebody get the answer, x subtract 1 over x plus 3? All right, the only way to get better is to practice with a great attitude. 12. Try again till we get it right. I know. I get it, me too. I can feel that way Tuesday morning, and Wednesday morning, and Thursday morning, and Friday morning. So how long are football practices? Like 2 hours every night?
like 30 or
3 or 4 hours? And then which is the night that you get to practice under the lights? Do you have one practice a week where it's nighttime? Because usually there's one practice a week where the football team practices under the lights. So they're used to like nighttime and lights because it's a little different, right, than daytime. Anyways, doesn't matter. That was too complicated. Too complicated. All good. DBL this week, right? We got this. So again, do we have the skill to factor, to make the denominators the same? Add or subtract? Then at the end, factor again to fully simplify it. Then be patient. When someone's done in your group, see if you have the same answer. If someone is stuck, allow them to try it, but support them as they keep trying to go forward. Try to do better. So I noticed the denominator. Did your spider sense go off? M plus 2, M subtract 2. A difference of squares. So to make the denominators the same, we multiply top and bottom by M plus 2. So if I put this all together, M squared, 5M plus 2M is 7M, and 6 plus 4, did you see the 4? Is 10. The denominator is plus 2 minus 2. Try to do the last step. The challenge step is make the denominators the same. And then the numerators, you might have to distribute, combine like terms to get to here. Now, can you do the next step? Strike out and see what the answer is. And sometimes during class time, you're not in the mood to like learn this. Like you're just waking up, you're copying. That's why we have this video. You can say hi to yourself, right? So that you can do this over again when you're ready and you're like there mentally.
Oh, I know it. Oh,
so what two numbers multiply to 10 and add to 7? 2 and 5. So M plus 2 strikes out, and your final answer is M plus 5 over M subtract 2. All right, I'm going to do the next one with you because it's a different technique. So I want you to look at number 13, and we're going to do it together. For number 13, you're asked to add, and in order to add, the denominators need to be the same. And before, what we looked at is one of the denominators was factorable. And then we went from that and we matched the denominators. Yes? Now, when I look at 13, they're both prime. What I mean by that is neither one is factorable. Like they are what they are. So then what do I do to make the denominators the same? And what we're going to do is we're going to take the other denominator and multiply top and bottom by it. So for the first fraction, the other denominator is W take away 7. And then for the second, the other denominator is W plus 1. So when they're prime, what must I do? Is take the other denominator and multiply top and bottom. So now are the denominators matching? Because you can multiply in any order. So did you see that technique? If you can't factor, what do I have to do? Take the other denominator and multiply top and bottom. So the denominators are the same. So I have 5W take away 35. I have 8W plus 8. You're not going to make a mistake with distributing. That's my common denominator. Keep going. Can you combine like terms? And I get 13W, subtract, make sure I do this right, to 27. And so what I look for is there a number that goes into 13 and 27 to simplify it? So it's in lowest terms, and you have your answer. Let's try that technique again together, and then 15 and 16 will end there. So 14, are the denominators the same? No. Are they prime or are they factorable? And because they're prime, how am I going to make the denominators the same? So what's the other denominator? So multiply top and bottom times b. So again, for the second fraction, what's the other denominator I'm going to use? b plus 3. Now look at it. Are the denominators now the same? Can you distribute? Be really careful of that subtract sign. So I have 4b plus 12. But when I combine like terms, my common denominator is b plus 3, b squared. But I'm going to subtract 4b. And I'm going to subtract 12. Now, let's do the next step. Is the numerator factorable? Are there two numbers that multiply to negative 12 and subtract to 4? Negative 4. So the two numbers that factor the numerator are negative 6 and positive 2. Now, look carefully. Are there any common factors that strike out? But would I know that? No, right? I have to factor it and know that there's no common factors that strike out. So that's it. That's in lowest terms. All right, number 15 and 16. And we're done today's lesson. Can you add and subtract rationals? That was my goal. The last sheet is going to be a homework sheet. I'll make a video on the homework sheet again. I'll share it again. And then this will be your quiz tomorrow morning. Adding and subtracting fractions. All right, let's make someone famous. Thomas, what should I do first? I'm feeling you're frustrated. I'm feeling that you haven't bought in that every day there's a quiz, and if there's not a quiz, there's probably a test, right? Like, you got to buy in to what we're doing, right? Yep. Doesn't your coach say respect the process, right? Respect the journey. It's not the end product, right? It'll take care of itself. So can you tell me in number 15 how I should start, or you can ask for help. Okay, how do I do that? What should be my first step to find the common denominator? Yeah, so the first step is we look to see if something's factorable. In question number 13 and 14, they were prime, so we used a different technique. But our first technique is it factorable? So look at the first denominator. How do I factor 4p take away 20? Well, they both have what number in common? And when you divide out of 4, what's left over? Excellent. Keep going, Thomas. Look at the second denominator and tell me how you would factor it.
p minus 5 and p minus 3.
So I want you to look at the denominators, and they have to match, right? So when I look at the first denominator, what does the second one have that the first one does not have?
P minus 3.
So both the numerator and denominator, I'm going to multiply by p subtract 3. Now, look at the second denominator. What's missing that the first one has that the second one does not? So, both the numerator and the denominator times 4. So, we're going to distribute. So, 2 times p and 2 times negative 3. We're going to do it again. P times 4 and negative 6 times 4. Yes?
Yes.
And the common denominator is going to be 4, p subtract 5, p subtract 3. Goodness. Diana, what would you do next? You would combine like terms on top? Okay, so what like terms do you see? And? Negative 24? What is that? Good. What other like terms do you see? What's that? Let's write it down. The denominator stays the same, and we want it factored. So we don't want to multiply it out, because we want to see if it can simplify. Daniela, does the numerator factor from there? So you can factor a 6. What are you left with? Is there a common factor in the denominator that would simplify this? So p subtract 5 strikes out. There's actually one more thing I could do. Do you see it? So 2 goes into both evenly. So 2 and 3. So the only thing left in the numerator is 3. And what's left in the denominator? 2 and p subtract 3. And that's it. Awesome. All right, one more person. 2 more people. Ready to be famous. Over 300 subscribers. I'm important. Number 16. Anthony. I don't get a chance to ask you as much as I should, but you're here. 16. Tell me what the first step is for number 16. Yeah, like are they the same? No. So my first step to make them the same is to factor. So how do I factor the first denominator? Excellent. And what am I left with? Okay, let's look at the second denominator. How do I factor it? Perfect. And what am I left with?
R plus 4.
Perfect. Let's see who's next. Dahlia. My goal is to make the denominators the same. So I want you to look at the first denominator and the second one and think, what's missing? What does the first denominator need that the second one has? So both the top and the bottom times r. Now, Dahlia, I want you to look at the second denominator. What's missing so they can be the same? So top and bottom. So r times r is r squared, and negative 8 times 2 is negative 16. Just for fun, I'm going to go 2 times r is 2r, and then r plus 4, and that's the common denominator. Jimena, what would you do next to simplify your answer? Are you telling me r squared subtract 16? And I always feel like a pirate whenever I say r when it's in a math question. But are you saying it's a difference of squares? So the square root of r squared, square root of 16, r plus 4, do you feel the pirate? R take away 4, 2r, r plus 4. Then you can say maybe. And then, do you see any factors that strike out? Oh, Melissa. Tell me how to finish this off. They could complain I don't ask enough of Melissa.
The r plus 4.
R, like a pirate, plus 4, strike out. Anything else, strike out.
Is it no?
No. What's left in the numerator?
R minus 4.
Yes, matey.
And then the denominator is 2r.
Perfect. Just need a parrot and crackers. All right, Mr. G Math. Over and? Perfect.